This is our last part of radical equations, and we are solving much more complicated ones. So to go and review algebra, first thing we have to do is always isolate the radical. So this right here needs to be isolated. So we add or subtract everything away, which leaves us with this. We can then square it then to remove the radical, and that'll give us the equation to solve. So same exact steps here. We're going to isolate it. So this one is fully isolated. It's all by itself. Over here they are not isolated, so we're going to have to choose one. So since this one's isolated, we can move on to the next step, which is to square it. And when you square it, you get 5x minus 1. Now this is why they're more complicated. This is not a clean square, so we're going to have to multiply it. So you can use the box method or FOIL, your choice. We have x minus 5 times x minus 5, because it is x minus 5 squared, which would give us x squared and minus 5x, and then plus 25. Putting it all together, we have x squared minus 10x plus 25. And there it is. So now that there's a square on there, we're going to have to use either factoring or quadratic formula. But both of them require us to set it equal to 0. So we get x squared minus 15x plus 26 equals 0. And this one is factorable, so I'm going to choose factoring over quadratic formula because it is quicker. So factors of 26 are 13 and 2. So this would give us x equals 13 and x equals 2. Now just like any radical from before, when we square them, we're introducing in possible incorrect answers. So we have to check and make sure it's correct. Because remember, if you square a negative, it turns positive. So if, say, we had negative 1 equals 1. That's the answer we had gotten. When we square it, it turns it true. So we still have to check them to make sure they work. Okay, so we're going to go down and check our answers. So we have x minus 5 equals the square root of 5x minus 1. And our answers were 13 and 2. So let's check these problems. So we have 13 minus 5. 5 times 13 minus 1. So that would be 8. And 5 times 13 is 65 minus 1. 64, which is 8. It checks out. Now let's check the other one. 2 minus 5. Okay, so that's 10 minus 1 is 9. And that's negative 3. It does not check out. So that is not good, which means we have to cross that one out. And so our only answer is 13. And that's what I was saying. If you were to square this, you would get 9. And when you square this, you get 9. So it works for the squared version, the version that we're creating after, but not for the original. So you still have to check them. All right, now for this massive one. All right, so what we have to do first is choose one we want to isolate. And I'm picking the positive one because I like to isolate positives, which means this one has to go. So we're going to subtract it to the other side, or in this case, add it to the other side. Now these aren't complicated, but they are very long. Okay, so now it's isolated. That's the whole key. You have to isolate first. Now we can square both sides. And we're doing the same FOIL that we did before here. So you have two terms and we have two parts here. So we have to do the same thing. So we take the first one. Because remember, this is square, so you're going to have to write it twice. So we're writing it twice. Remember, 2 plus square root of 2x minus 4 squared would be 2 plus the square root of 2x minus 4 times 2 plus the square root of 2x minus 4. So that's why we're doing the box. You can also use FOIL. Alright, so 2 times 2 is 4. 2 times this, same rule, outside with outside, inside with inside. So we basically just write them together. And then the same thing here. And then that one times itself, that's our whole rule. We're getting a square version, so we're getting this. And it cancels the square root to leave us with 2x minus 4. Now we can take and combine all like terms. So we have a 2x. We have a 4 minus 4. So those are going to cancel. And then for the radicals, we have 2 of these and 2 of these for a total of 4 of the square root 2x minus 4s. And then this cancels the radical. Okay, so we isolated one radical, squared both sides to remove the radical, and then now we still have a radical. So we need to isolate this one. This needs to be all by itself, which means we have to get rid of the 2x and the 4. But you can't just subtract 4, can you? You're going to have to divide. So we minus the 2x to the other side, and we get x plus 4 equals 4 square root of 2x minus 4. Okay, and so you have an option here. You could just square this and square both parts and then distribute, or you can divide by 4. Now I like to just think of it as this, all by itself, and isolate it. So that's the way I'm going to do it. So we can now square it and square it. And that would give us 4 squared, which is 16. And then the square would cancel that square root and leave us with 2x minus 4. So again, 4 squared is 16, and then the square of this is this. The reason this gets a box or a FOIL method is because the plus. We have 2 parts. This is all one part. And then over here, we've got to do FOIL or box again. I told you these were tedious. They're long. So we have x squared, 4x, 4x, and 16. So putting all that together is x squared plus 8x plus 16. And now if we distribute, we get 32x minus 64 equals, and now we have no more radicals. So we do the same thing we did over here, which means to put everything on one side so that we can factor or use the quadratic formula. So that gives us x squared minus 24x plus 80 equals 0. And then we'll factor it. So 80 would be 8 and 10. That gives us 18, 20, and 4. So x minus 20, x minus 4. So that gives us x equals 20, and x equals 4. And we're still not done. We still have to check them. So let's take our original equation all the way to the bottom. Square root of 3x plus 4 minus the square root of 2x minus 4 equals 2. And now we're going to plug in 20, and we're going to plug in 4 and see if they both work or if only one works. We'll find out right now. So 3 times 20 plus 4 and we get that, and that checks out. So now let's try the 4. And the 4 checks out as well. So we have 2 answers right here. So just to go over this one more time, because it's very tedious, you pick one of them. It doesn't matter which, but you isolate it by bringing the other one over. And then that way, when we square it, it will actually cancel the square root. But the other side is going to be a lot of work, and I choose box method to keep it organized. Make sure you add your like terms. Once you get that, you will now have another equation with a radical. You isolate that radical so that you can square both sides to remove the radical. If you end up with a quadratic, you have to set it equal to 0 and solve, and then check your answers. And if they both work, it's correct.